Okay. Okay. So recently one development was there that I surrendered 2 of the TAs to the institute. So now we have only 2 TAs. 2 are gone. Who? One student, MTech student who was from the final year. So fourth semester MTech student, 2020-11 ID. He has gone. He is gone. Another girl named Jui, Jui. So these 2 people are not serving us. Only 2 remaining are left with us. So in case you are writing mail to any TA, you should write to these 2 only. These 2 means remaining 2 only. I am not. One name is Vyom. Another is, her name is from A. So you write to them only. Okay. So in the last class, I gave you this assignment, and many of you submitted the answer very enthusiastically. Rather, before I could make a link for submission, 2 or 3 submissions I received on my email. That since you said that first 10 would get bonus marks, therefore I am sending it to you by email because there is no place on Moodle where I can submit it. So thank you very much. So we received 34 submissions, and my promise was that from the first 10 submissions, the submissions which are right, the answers which are right should be or would be given the bonus marks. I have not seen your answers. 1 or 2 answers I opened and I found that you did a nice job. Okay, so we were on this slide at the end of last class. So what does it show you? What does it tell you? Anybody? Yes.
Sir, sorry to interrupt, but can you share a solution for that Spider-Man, that web problem for those who
That
have
I
not...
will. That I will. That I will.
Thank you.
Right now, please focus on the class.
Thank you, sir.
So, what does this slide convey you? Today's slide, I have also added some uh, description of these images, captions of these images. In the last class, it was not there. So the top left is the original solid structure made of spherical atoms, right? And the bottom left is the solid structure which is below the surface. So I have eliminated all the atoms which are appearing on the surface. Okay, this cube is of 5 atoms on its edge, and therefore it has 5 into 5 into 5, 125 atoms in this structure, solid cubical structure, right? 125 atoms. Of those 125 atoms, the atoms which are below the surface, 1 atomic layer inside, are only 27. Those are depicted by these pink colored spherical atoms. So this is a 3 cube, a structure which is having 3 atoms on its edge, right? Meaning remaining 98 atoms were on the surface. Surface appearing atoms were 98 of the 125 atoms which was making this complete solid structure. So the percentage of surface appearing atoms is around 80%, 78.4% to be more precise. So how did I calculate, or how can you calculate this? So you can slice off one atom each layer from all these 6 faces. Since it is a cube, it has 6 faces, right? You can slice off one atom thick layer from each of the faces. So which is shown in highlighted today. So it is shown in this figure. So first I took off these 2 layers of 5 atom side. So 5 by 5, 25 and 25. So 50 atoms I took off from this solid structure. Then I took front and back. So this 3 into 5. Because these 2 side atom layer are already removed. So I am left with only 3 atoms, 3 into 5. So 15 into 15, 30. So 50 plus 30, 80 atoms I have removed now from the surface. And now I am removing the 1 atom thick top and bottom surfaces. So now, since from each of 4 sides 1 atoms are gone, 1 atom layers are gone, therefore we are left with only 3 by 3. So 9 plus 9, 18. So 50 plus 30, 80 plus 18, 98. So 98 atoms are on the surface of this solid structure, which are blue colored. Once I removed, stripped all of them, I am, or we are left with this part of the solid structure, which is certainly lying on below the surface. So this is 3 by 3 by 3. So 27. Another way to look into this 3-dimensional structure is that you can stack up all these, or you can open up in this form. This structure can be opened up in this form. So slice off the bottom layer of 5 into 5, 25 atoms. It will expose this layer. It will expose this layer, and that is how you can make, by stacking up, you can make this structure. So this figure or this diagram shows you that how you can calculate or how you can find out number of atoms lying on the surface versus number of atoms lying below the surface. So now this is a tabular description or presentation of such cases, that in the bottom that 5 atom case is shown. If instead of 5 we have 10 atoms on the edge, so 10 into 10 into 10, a cube of 10 to 10 into 10 spherical atoms by arrange, then total number of atoms is 1000, 10 to the power 3. And if you calculate number of atoms appearing on the surface in terms of percentage of the total number of atoms, then you will find that 50% of the atoms lie on the surface in such case. So just by increasing your number of atoms or your solid structure, so just by increasing surface to volume ratio, what we call surface to volume ratio, the percentage of atoms appearing on the surface decreased from 80 to 50. And if you go on like this, so from 10, if you make it 100, so 100 into 100 into 100 spheres solid structure, then certainly total number of atoms is 10 to the power 6. And if you calculate similarly, you will find that only 5.8% of total atoms will lie on the surface, and rest of all, so 94.2% of the atoms will lie below the surface. So surface appearing atoms, in terms of percentage, is reducing. On the other hand, I have also given that let us assume that each of these atoms are hydrogen atoms. So you know that the radius of hydrogen atom is, or the diameter of hydrogen atom is called is 1 angstrom. So Bohr radius is actually defined as the radius of one isolated hydrogen atom, and that is therefore 0.05 nanometer. Okay. So if this is the case, then a solid structure or a cube of 100 atoms on its edge, or 10 to the power 6 atoms, has the size of 10 nanometer. And if we go on and on increasing upward in terms of size of the cube, and what you see is that if the cube is of 0.5 nanometer length or side, it has 80% atoms lying on the surface, and of the same atom, if the cube becomes larger of 1 millimeter side, then only 0.00006% of atoms are lying on the surface. So surface lying atoms versus volume decreases drastically as we go on increasing the size of the solid. Right. And in the last class, if you recall, I mentioned you that since all actions take place on the surface itself, therefore surface lying atoms are actually responsible for all the chemical and physical properties of the structure, solid structure. We are not talking of liquid or gases, because in case of liquid or gas, or rather fluid, it is very difficult to define shapes in this form. It is very difficult. Therefore, we are right now talking just about solid structures. And in case of solid structures, physical and chemical properties are actually based on the surface lying atoms. He gave certain examples of electroplating or polishing or many other ways to change the surface appearing atoms or layer, and thereby the property does change that we mentioned or that we discussed in the last class. And here we are seeing that since percentage of atoms on surface are changing, therefore it is certainly going to impact the property of the structure or solid. Okay, so let us, based on this example and the resulting this table, Harsh, वैसे गाना बड़ा अच्छा था, लेकिन ऐसा किया मत करो. Keep yourself mute. So the assignment given to you is that suppose you have a solid cube of n cube spherical atoms, meaning that one side of the solid cube is of n atoms, n spherical atoms, and we are making a cube, just like I gave you example, n is equal to 5 example I have just given you. So I want a generalized formula for such type of cubes, that how to find out the formula for calculating the number of atoms available on the surface in terms of n. Right now the example that I gave you in terms of numbers. Now you generalize it in terms of n, so that if I replace n by some integer 5, 10, 15, 20, I can get immediate answer for that. And again the same way to submit the assignment is like the fastest finger first. The correct answers or the first 10 submissions will get bonus 3 marks each. Mail mat karna. The same link is open there and you can submit it there. The file name, write your ID and date, so that I can differentiate which one is for what. So date of assignment, so today's date. Even if you are submitting tomorrow, write the date of assignment. Okay. So there is one example. Yes.
सर वो असाइनमेंट 1 सबमिशन लिंक है उसी में सबमिट करना है?
हाँ उसी में करो.
ओके जी सर.
So to differentiate your submission is the date of assignment would change. So we will keep the same link open throughout the semester for such type of quick assignments, and the differentiation I could make using the date of the assignment given to you. If you are submitting, you have to write your, let us say, ID. So 2020-01-008 underscore, what is date today? 1st February 2022. Or whatever you want. But this date I require to differentiate between the assignments.
Sir, if we have submitted the previous assignment, so we have to just edit the assignment, no? We have to just
Edit?
yeah.
Edit means what?
If we have submitted the previous assignment, the Spider-Man wala, so then we have to just remove that submission and
Why do you want to remove it?
means in the same link it would not means
Allow more than one submission?
yeah. So we have to just edit submission. So
No. Don't remove it. Let me check. I will allow multiple submission from each ID.
okay.
Okay. Don't remove your, because I have not, neither I have downloaded it nor I have evaluated. So if you remove, you are gone. It is your loss.
Okay.
Okay. So here is one example. Here is one example. And with this example, I want to convey you that by just changing few atoms from here and there, we can change the property. So this is one example which is reported in 2008 in this paper of journal Physical Review Letters. And this example says that a gold nanowire containing 20 gold atoms embedded with oxygen molecule conducts, whereas a reduced length of wire containing only 6 gold atoms becomes an insulator. Meaning, just visualize that there are two, suppose copper plate, or let us assume that there are golden plates जिसके थ्रू मैं एक बैटरी या एक सर्किट कनेक्ट कर रहा हूँ, right? Between these two plates there is one nano wire of gold to make the circuit close. Okay? We all know that gold is a very good conductor, electrical and thermal both. Okay, so there is a gold nanowire. Now the condition here is there are two cases. One case, there are 20 gold atoms in this nanowire. In another case, there are only 6 gold atoms in this nanowire. Nanowire means of the dimension of nanometer. So the observation says, or this paper reported, that in case of 20 gold atoms, this wire conducted. So there was a circuit which completed. So मान लो उसमें I have kept one bulb, then bulb glue. But the moment I reduced atoms from 20 to 6, so I just removed 14 gold atoms. Mind it, we are working at atomic level. So just by removing 14 gold atoms from that nanowire, the same circuit does not work. So bulb did not glow. So this nanowire, even though there are gold atoms there, it became insulator. So physical property of or electrical property of gold atom changed. However, we know from our standard knowledge that gold at macroscopic level in our world always conducts. So there is a difference when we come from or migrate from macro level, macro world to micro world. Micro bhi nahi hai ye, this is nano world. Micron is 10 to the power minus 6, nano is 10 to the power minus 9 in terms of meter. So when we migrate or shift from meter scale to nanometer scale, we see these type of extraordinary phenomena, which is not possible in our world. So this is in another way saying that we have engineered this material. We have changed the property of gold just by reducing, just by eliminating some atom. The same paper, another observation reported was that when individual, so now we did not discuss the presence or the significance of oxygen molecule. Basically, this oxygen molecule is playing very important role because the extra charge accumulates near those oxygen molecules, which helps in conduction. Okay, so when we reduce number of gold atoms, those charge concentration reduces, and therefore it does not conduct. It becomes insulator. But this happens in the presence of oxygen molecule. Now, another observation was that in place of oxygen molecule, if we use only oxygen atoms, then this nanowire's magnetic properties also change. So magnetic property emerged at nanoscale when their bulk form does not have these properties. So two types of electrical and magnetic property of the same material has changed just by replacing some atoms or molecules in the structure. And here is its pictorial description. The two side golden structures are basically those conducting plates. Okay, so they are at macro level. Macro level. तो जो हमारा यूजुअल जो सर्किट होता है उस तरीके का स्ट्रक्चर. Connecting these two plates is that nanowire, which is shown by this red arrow. It is shown by this red arrow. These blue areas are the excess charge density, which is concentrated in presence of oxygen molecule. These yellow one is inside. These are the 5 gold atoms, and inside these two area, there are the red which you see are the oxygen molecule, which we just read in the previous slide, that when we use 20 gold atoms with oxygen molecule, this circuit conducts, and when we reduce it to 5 or 6 gold atoms, this does not conduct, this becomes insulator. So this is the phenomena that we observe at nanoscale, and the conclusion is that just by changing few atoms, we can see, observe, find, notice different physical and chemical properties. So why it happens? Let us spend some time in discussion. Why it happens? So we know that at our macro and micro, though these two sound almost similar, but these are different. Macro, whenever I say macro, it means we are talking at centimeter or meter scale. Sorry. And whenever I say micro or nano, micro is 10 to the minus 6, nano is 10 to the minus 9. Okay. So when we talk about molecule, we are actually wandering around or in the macro world, to meter scale. And that scale, these molecules are primarily defined by 3 basic bonds, which are ionic bond, covalent bond, and metallic bond. Okay? Is there any other standard bond that you know of which define a molecule? Hello?
Sir,
Is there any other bond that you know of which can define a molecule?
so can we consider coordinate bond?
No. Can anybody define what is metal bond or metallic bond? Can anybody define or tell me about metallic bond? What is metallic bond?
Hello, sir.
Yes.
Yeah, so like in metallic bond, there is a structure where all the atoms are remain in the center part, and the electrons, the valence electrons, form a small layer around the metal surface. So the atoms form form of a kernel in between the in the central part. So it
So what is
appears as
bonding
kind
there?
of a structure.
In what way you define that they are bonded?
In the form of metallic bond.
हाँ, so metallic bond में bonding देखो, ionic bond में we know perfectly that one valence electron is gone to the other atom, and therefore there are ions created, positive and negative. जिसका electron निकल गया, that has become a positive ion, and who accepts the electron of the other atom, it becomes negatively charged ion. And then between this negative and positive charged ions, there is a strong force of attraction that bonds these two atoms. Right? Right.
Yes,
Yes, sir.
sir.
मेटेलिक बॉन्ड में क्या हो रहा है, कहाँ, वेयर इज दैट फोर्स ऑफ अट्रैक्शन दैट बॉन्ड्स दैट पुट्स द स्ट्रक्चर टुगेदर इज फॉर्म?
It's
So
a
in
electrostatic attraction.
metallic bond, we have electrostatic attraction between free electrons and positively charged metal ions.
So you are saying that in this also electron is discharged or getting released from the parent atom?
Yes, sir. In
They are free
in
electrons
bunch
from
of
positive atoms.
Sorry, come again.
They are the free electrons that are present in the positively charged cations.
Are the free electrons. तो बॉन्डिंग किस में हो रही है, अट्रैक्टिव फोर्स जो जनरेट होगा वो किसके बीच होगा?
Yeah, so sir, actually, what happens is, if we take two sodium metal atoms, so sodium becomes sodium plus, both the sodium, and they release one electrons. So there is a electron cloud of 2 electrons, and that electron cloud binds them together like that.
Okay, so I will suggest everybody to study metallic bond. What is the difference between metallic bond and ionic bond and covalent bond? All. So that we are going to use this concept in maybe in 2 or 3 weeks later class of when we start semiconductor material, because it is very important for you to understand the difference between metallic bond, how these electrons behave. Are they actually released from their parent atom, or what is the three-dimensional structure of that solid? We say that it is bonded because of metallic bond. Somebody was trying to say something.
Yeah, in a metal, when for example, sodium ion will release will have loosely bound electrons, so it will form Na plus ion. So when two neighboring Na plus ions will have positive charges on them, so they will repel each other. So what will happen is that from there will be a repelling force from all the sides on one particular atom. So it will get fixed at one particular position, and will have some loosely bound electrons to it, which
नहीं
will
नहीं
not.
no no ठीक है. So let us stop this discussion here. I suggest you all to refresh yourself about your knowledge of metal bond. We require this knowledge not exactly right now, but after 3 or 4 weeks when we start studying about semiconductor material. Fine. Now, come back to the example of this nanowire of gold. Here, just visualize. Don't go into the actual detail of how this type of switch is formed. Just visualize that when I said that if we remove gold atoms one by one from 20 till we reach to 6 or 5. So how can it be possible? Can I pick one single atom and remove it or add it somewhere? Is it possible? Does anybody know if we have isolated one single atom? Theoretically, yes. Theoretically, yes. Or rather, empirically also we have used. जो मेडिसिन जो हम लोग बनाते हैं उसमें तो यही थ्योरी काम करती है. But practically, do you have any knowledge or information that we have isolated single atom, जिसको हम पकड़ के दिखाएंगे आपको लैब में कि देखो ये रहा एटम ऑफ कॉपर और ये रहा एटम ऑफ कार्बन, सिंगल एटम, not a cluster of atom or not a molecule of atom. Okay, think about it. Think about it when we say that we have removed some atoms or we have added few atoms. Think about it. From that, I would like you to get a clue that it is not necessary. Macro world mein it is necessary to have molecules to create a structure. For molecules, we require bonding. For bonding, those bondings are the firm bonding. Firm bonding. इसके बेसिस पे मैं सरफेस एपियरिंग एटम और बिलो सरफेस एपियरिंग एटम की बात कर रहा हूँ. If I cut open a solid, then certainly I am actually what we are. कुछ कट करते हो तो why do you require a force to cut that? एप्पल कट करने के लिए डिफरेंट फोर्स तुमको लगाना पड़ता है, लेमन कट करने के लिए डिफरेंट फोर्स लगाना पड़ता है, और वुड कट करने के लिए यू नीड डिफरेंट टाइप ऑफ फोर्स. व्हाई डू यू रिक्वायर फोर्स? और वेयर दिस फोर्स इज एक्चुअली अप्लाइड? क्या कर रहा है? व्हाट डज दिस फोर्स डू? द नाइफ or any razor or any cutter's force, what does it do? पेपर कट करने के लिए तुमको उतना फोर्स नहीं लगाना पड़ता है. द टाइप ऑफ फोर्स यू रिक्वायर टू कट अ वायर. जैसे कल हमने बात की ना, वो डायनासोर नहीं, क्या, स्पाइडरमैन. स्पाइडरमैन अपने वेब से is trying to stop the train. That force that a Spider-Man was required to use or apply had to counter the force exerted by the train. Full body mass of the train plus the passengers which are on the train, सारे का जो force है, उन सारे का जो mass है, mass into acceleration, that force or momentum, mass into velocity by which the train was moving, that momentum the Spider-Man had to counter, resist. For that, he is applying his force of web. That force from the web is coming from the Young's modulus converted force, which is natural to the web. Similarly, here for cutting any structure, why do you require a force? Actually, which force you are countering? Anybody? बोल भाई, ये तो क्वेश्चन इतना मुश्किल नहीं है. Why are you so silent today? नाम पुकारूं? आशका, आशका बताइए इसका आंसर. आस्था, आस्था, आस्था जगदीश शेट्टी. क्या है? व्हाट इज द प्रॉब्लम? मिलिंद पटेल.
Yes, sir.
Who are you?
The answer.
What is your name? Very strange. Am I audible or not?
Audible.
तो बता क्यों नहीं रहे हो यार कोई? मैंने नाम लिया आस्था, मैंने नाम लिया आशका, मैंने नाम लिया मिलिंद पटेल. Nobody responded. Where are you guys?
Trying to think.
Trying to think. But what is your name? Who is trying to think?
We need.
Vinny. Aditi? Das. Do you have any answer? Dev Darji. अरे कम से कम हाँ या ना तो बोलो. ये तो बोलो कि नहीं साहब, आई डोंट हैव एनी आंसर. देवांशी पुजारा.
Yes, sir.
बोलिए, डू यू हैव एनी आंसर टू
Hello.
दिस क्वेश्चन?
Uh, sir, let me just clear the question first. Were you asking that what we do when we cut the objects?
What we do नहीं. Why do we require force? Why do you experience different type of forces? Like I gave you example. If you have to tear a paper, you require very feeble force. But you have to cut a cable, you require a different
Yes,
force.
sir. So, yes, sir. So the answer would be that the bonding among the atoms or the molecules of that uh, of the particles of the surface have different bonding forces. So we have to um, proportionately change our force to counter them.
Right, and that is not on the surface only. When we are cutting something, we are cutting it through and through. तो पूरे वॉल्यूम को मैं कट कर रहा हूँ ना.
Yes, sir.
So it depends upon what atoms they are made of and what is the bonding force between those atoms. जिस layer को मैं cut कर रहा हूँ. So when I cut something, actually what we are doing, we are exposing. Cutting के पहले everything was below the surface, right? Now we have exposed. दो surface मैंने create कर दिया by cutting that solid. पहले एक था, अब दो कर दिया. So on those two new surfaces, what we have done is that we have made some new atoms appear on those surfaces. And those two atoms are certainly not as inert in terms of electronic property as their below surface atoms. Below surface atoms have all those valency full. But जो ही मैंने उनको कट किया, जो दो एटम के बीच का बॉन्ड था वो मैंने ब्रेक किया, तो certainly they are now looking for at least one electron or one new atom to be bonded with. So now they are chemically more active, or rather they are reactive now. So two highly reactive surfaces we have created by cutting a solid. और इसलिए हर सरफेस का हम एक केमिकल पोटेंशियल भी मेजर. And therefore it becomes very prudent to understand how reactions take place at surfaces. Now this is the picture that I am asking you to visualize at macro scale, meter scale, centimeter scale पे मैं बात कर रहा हूँ. But what will happen if I go at nano scale? We have just seen that at nano scale, most of the atoms are lying on the surface itself. When we used 125 hydrogen atoms to make a cube of a side of 5 atoms, then what we found? We found that Out of those 125 atoms, 80% of the atoms, 98 atoms were present on the surface. Suppose we shrink more. The example that we just gave in the previous slide, of 20 atoms only of gold, perhaps all those 100% atoms will appear on the surface. Nobody will be inside or below the surface or in the meat of the solid. Everything is on the surface, stark, naked, exposed for any reaction to take place. We will happily accept any reaction. None of those atoms would feel discarded or underprivileged. Everybody is at the same opportunity level for interacting with anything which is coming in the vicinity of them. So by means of any technique in which I can add or remove atoms at nanoscale, actually what we are doing is we are not making molecules, we are making clusters. The term is cluster. We are making clusters at nanoscale. And that can change their shape anytime, spontaneously, instantaneously, just by changing forces around them. Whereas in case of molecules, they are fixed. They cannot make any difference. Water will remain water. Whether you take it in a spoon, you take it in a glass, you take it in a water bottle, you take it in a thermos, in a bucket, in a tank, wherever you take, water will remain water because molecules are molecules. But in case of clusters, I can change. In case of clusters, therefore, I can change the property. In case of clusters, therefore, I can change their behavior. And these clusters are defined not by those fixed strong bonding, but these are defined by van der Waals forces. Some of those van der Waals forces are listed here. Hydrogen bond is one type of van der Waals force. However, hydrogen bond makes water. London force, there is, so these forces which can change their strength, their bond length on just spontaneously or instantaneously just by some feeble change around them. These forces are actually dipole-dipole forces, like you were trying to define metallic bond just now. We create dipoles first. How dipole? Atoms are neutral, charge neutral. Their center are positively charged and around them electrons are revolving. Okay, we all know that these electrons are in a form of clouds, are not fixed. So these are the probability of finding electron in that orbit. That is what define these electrons location. So when it is in form of cloud, then it is quite possible that at some point of time the charge density, electron charge density at some particular space might be more than on its opposite side. So that part is more negatively charged. And immediately the neutral atom, howsoever neutral is the atom, it can become electronically charged either positively or negatively on one side or other side of it. The moment it becomes positively or negatively charged on some particular side, what happens is that it can, by virtue of what is the name? So a negatively charged particle can charge its neighboring particle as positive, right? क्योंकि वो नेगेटिव चार्ज को वो डिस्प्लेस करेगा और repel karega, and therefore the neighboring atom will become positively charged on that side, and then this negative and this positive will join together, will create an instantaneous attractive force between these two, and there will be a dipole-dipole interaction that would start. So London force is defined because of that sloshing nature of electrons revolving around the nucleus. Casimir force range is at angstrom level. So these clusters, in case of these such clusters, we can actually change atoms, we can add atoms, we can remove atoms, because these are not permanent structures of the solids, and thereby we can change the physical or chemical properties of structures at nanoscale. At nanoscale, mind it, not at macro scale. Here I have given you two examples. Though they look like structures of macro scale, but imagine them at nano scale. So imagine that each of these smaller cube side is 1 nanometer, or assume that these are, suppose these are hydrogen atoms. Assume that these are hydrogen atoms. Now, in case of this well-structured cubical form of the solid made of individual hydrogen atoms, so 1, 2, 3, 4, 5, so 125 hydrogen atoms are making this beautiful cube, you can see that these are numbered. And what these numbers mean? Certainly, wherever 1 is written, you can see that out of the 6 faces of that cube of atom, only single face is available or exposed to interact with any other atom, neighboring atom. Only one. 5 faces are within the surface or below the surface, right? Wherever 2, integer 2 is written, you can see that those are on the edges. And a different type of edge where only 2 faces out of the 6 faces of that cube is exposed to interact. And there are 8 cubes which are even more privileged, having 50% of their faces able to interact with any neighboring atom. Those are these corner atoms. This, the 4 on the top and 4 at the bottom. So these 8 are actually most sensitive or most reactive atoms of those 125 atoms. So this is how reactivity, locational reactivity. So when we are talking or we are operating at nano scale, location also has some advantage or disadvantage. So property at this end will be different from property at this end. So if you are making a sensor out of a cluster of, let us say, 100 atoms, the response of that sensor will be different in different direction of that solid structure. On the other hand, this second solid has very different or arbitrary or random structure. And now, here, what these numbers denote. Here I have put numbers in reverse order. So wherever you are seeing number 1, these atoms have 5 phases exposed for any reaction. Only one is not available, which is touching with another bottom lying atom of the same solid. Wherever 2 is written, 4 of the surfaces are available for interacting with any atom which is lying in the vicinity. तो अगर डायपोल डायपोल इंटरेक्शन देखना है तो this one atom is most reactive or most powerful dipole that is going to be created in presence of any neighboring atom or dipole. And where 5 is written, only one surface is available. So the force of attraction for this 5 is the weakest. Force of attraction, cumulative resultant force of attraction for this one is the highest. So this will behave differently. This will behave differently. And therefore, overall the structure will behave differently than if I bring this cube in this groove. Then instead of 1, it will become 5. Only one surface will be now exposed. So the moment I replace even the location of the atom from this place to that place, the property of this structure will change. This all explanation is just to understand this experiment. It was reported in 2008 in Physical Review Letter. Okay, so now with this example, I am going to end today's class. The example is, you must have must be knowing that at hills, at high altitude places, water boils earlier than at sea level. Therefore, the practical question that you might be responding to in the standard 8th or 9th of physics, that why rice is not cooked well in hills, or why it takes longer to cook rice at hills, or ice callow, yeah, pulse callow, whatever. Any answer?
Because boiling point is lower, because basic definition of boiling point is that humidity, तो प्रेशर होता है ना एटमॉस्फेरिक प्रेशर, उसके इक्वल होता है ना जब ह्यूमिडिटी का प्रेशर, तब बॉइलिंग पॉइंट होता है. जैसे जैसे हाइट बढ़ती है तो एटमॉस्फेरिक प्रेशर कम हो जाता है, ये बॉइलिंग पॉइंट लो हो जाता है.
हाँ, you are right but not very right. Humidity कहाँ से ले आया?
Sir, I think he's talking
Sir,
about
means partial
Sir,
pressure
like-
of liquid equals atmospheric pressure, then only liquid will boil, start to boil.
Partial pressure? Which pressure?
Partial pressure of liquid.
Partial pressure क्या होता है? What is
Sir,
partial?
it is the pressure that was acted by gas of that molecules which are produced from liquid.
Pressure कैसे define करते हो? In terms of force, what is pressure?
So pressure is force per unit area.
तो partial pressure क्या होगा?
सर टोटल जो प्रेशर लग रहा है उसमें से, जैसे एक गैस में एक जार में नाइट्रोजन भी है, ऑक्सीजन भी है, तो थोड़ा सा प्रेशर है वो ऑक्सीजन की वजह से लगता है, थोड़ा सा प्रेशर है नाइट्रोजन की वजह से. तो अगर कोई पूछे कि खाली ऑक्सीजन का प्रेशर कितना लग रहा है तो वो पार्शियल प्रेशर ऑफ ऑक्सीजन।
तुम कहाँ उसके आंसर को जस्टिफाई करने में
Vapor pressure instead of partial pressure.
तो
like
मतलब
come back to boiling.
I mean
Come
the
back to boiling.
terminology
What? How do you
confused.
define boiling, my friend?
Like the terminology got, I guess, confused. He like the vapor
अरे
pressure should be
छोड़ो
equal
छोड़ो
to
जाने
the.
दो. I am not going to correct the terminology. Come back to boiling. How
Yes,
do
sir.
we define boiling?
Yes, sir. So boiling point only when the vapor pressure for the liquid equals to the pressure surrounding. Like for this case, it would be the atmospheric pressure.
And what is liquid pressure? Or pressure of the liquid means what?
The vapor pressure, you mean?
Ah,
It would be like any liquid has some of its molecules in vapor form. So the pressure exerted by those molecules in the vapor form on the liquid surface.
so when it is equal to atmospheric pressure, then
The liquid starts boiling.
जो स्टैंडर्ड बॉइलिंग पॉइंट होता है ना वो सी लेवल पे जितनी हाइट पे जो प्रेशर होता है ना उससे हम डिफाइन करते हैं। बट जब हम हिल टॉप पर जाते हैं तो जो सी लेवल होता है वहां पर प्रेशर होता है ना उससे स्लाइटली कम होता है। तो स्टेशन पे प्रेशर कम हुआ तो वो वेपर प्रेशर भी उससे मतलब कम वेपर प्रेशर पे वो बॉईल होना स्टार्ट हो जाएगा।
Yes, sir. And because in the hills the atmospheric pressure is lower, the liquid boils faster, and thus less heat is required to boil it. और क्योंकि less heat हम लोग ने अप्लाई किया है बॉईल करने के लिए तो वो बराबर से कुक नहीं हुआ है।
बट मतलब कि वो बॉइलिंग वाटर का अगर हम सी लेवल पे अगर हम बॉईल कर रहे हैं तो वो 100 डिग्री पर होगा। और अगर हिल स्टेशन पे कर रहे हैं तो स्लाइटली कम होगा। तो मतलब जो राइस को हायर हीट मिलनी चाहिए वो नहीं मिलेगी इसलिए अच्छे से कुक नहीं होगा।
मैं जो सुनना चाह रहा हूँ वो आ नहीं रहा है. Anybody else? So where I want you to come was what is happening in this case. There is a liquid, there is a vapor pressure on its surface. Till that point, everything is honky dory. वो वेपर प्रेशर कैसे है? वेपर प्रेशर मीन्स वहां पे जो उसका वेपर है बिल्कुल ऑन द सरफेस, बिल्कुल एटम एट few atomic layer on the top of the surface of that liquid. वहां पे उसी लिक्विड के, तो मान लो ये वाटर की बात हम लोग कर रहे हैं तो वाटर वेपर इज प्रेजेंट देयर. बॉइलिंग हम किसको कहते हैं? व्हेन द सरफेस एटम्स ऑफ दैट लिक्विड स्टार्ट escaping in the air. सरफेस एटम कब स्टार्ट, वो सरफेस एटम को कौन होल्ड करके रखे हुए? सरफेस एटम हैज सम बॉन्डिंग with its just below surface atoms, right? There is a chemical bonding between the top surface atoms and just below surface atoms. There is a chemical bonding. पानी के केस में वो हाइड्रोजन बॉन्ड है, जिसके कारण वो अपने नीचे वाले लेयर के साथ अटैच्ड है, नीचे वाला लेयर उसके नीचे वाले लेयर के साथ अटैच्ड है. And for letting the topmost atomic layer released or removed or escape, what do we require? We require to overcome or counter this atomic bond or bond strength between top layer atom, hydrogen atom or H2O molecule and just below. दोनों के बीच का जो फोर्स है जो इनको पकड़ के रखे हुए है टॉप लेयर को, उसको मुझको काउंटर करना है, ब्रेक करना है. To break that, I need some energy. That energy is supplied to this system by heating. ओके, हीटिंग हम बॉटम में कर रहे हैं, तो बॉटम से टॉप तक ये हीट एनर्जी बाय वर्च्यू ऑफ वेरियस मींस, कन्वेक्शन, कन्वेंशन, रेडिएशन, जो भी कहो, उसके थ्रू वो ऊपर तक आ रहा है। एंड इसको एटमॉस्फेरिक प्रेशर भी नीचे दबाए हुए है। So when I give sufficient amount of energy to the top layer atom so that it is more than, जब तक तो एटमॉस्फेरिक प्रेशर और ये बॉन्ड या वेपर प्रेशर इनका बराबर है, तब तक वो इक्विलिब्रियम में है, वहीं रुका रहेगा। द मोमेंट दैट वेपर प्रेशर or the moment I gave energy to the top layer of H2O molecules, which will overcome this atmospheric pressure, it gets released from the top surface. The top surface से वो एक layer release हो गया, फिर next layer will come on the top and again it will acquire the energy and it will get released. So basically this boiling phenomena depends upon how much counter force or downward pulling force I am applying to this surface lying atoms. How much downward pulling force I am applying to this surface lying atoms or molecules. Right. ठीक है, उसके बाद तुम लोगों ने सही कहा कि चूंकि हाई एल्टीट्यूड लोकेशंस पे एटमॉस्फेरिक प्रेशर कम है, इसलिए ये आसानी से ओवरकम कर जाता है एंड इट बॉइल्स अर्लियर बाय एडिंग लेसर एनर्जी। क्योंकि लेसर हीट या लेसर एनर्जी ऐड करने से बॉइल करने लगा, देयरफॉर राइस गेट्स रिमेन्स अनकुक्ड। ऑल दोज वर करेक्ट, बट the point that I wanted to make you to understand or visualize here is that the downward pulling force in case of macroscopic structures certainly would be much more higher than, अगर मान लो कि सारे के सारे एटम्स केवल सरफेस पे ही है, so there is no below surface atom, so there is no downward pulling force. तो जो ही तुमने उसको एनर्जी ऐड किया, वो एनर्जी विल ओवरकम द एटमॉस्फेरिक प्रेशर एंड इट विल रिलीज। या मान लो केवल 5 लेयर का ही वो सॉलिड है, 5 atomic layer solid is there, not 5 million or 5 billion atomic layer. तो फिर सारा का सारा लिक्विड will very quickly will boil. Therefore, it is also said, observed and utilized that at nanoscale, boiling point reaches earlier than at macro scale or meter scale. At nanoscale, boiling point reaches earlier than, तो वाटर को ही अगर नैनो स्केल पे इमेजिन करो तो वो हो सकता है 5 डिग्री 10 डिग्री पे ही वो बॉयल कर जाए। दिस 5 or 10 is just metaphorical, just to give you a difference that instead of 100 degree it boils earlier, much earlier, क्योंकि एटमॉस्फेरिक प्रेशर तो वही रहेगा, लेकिन यहाँ पे सारा का सारा जो हीट है that is going to directly to the top lying atomic layer and it will gain the energy quickly, much quicker than the earlier case of macroscopic world. So this is one very typical example of how at nanoscale we can engineer materials, we can arrange materials such that we can manipulate their properties. With this note, I am closing today's class, and we will start from this slide in the next class. Okay. Stop recording here.